All right, we're looking now at graphing sine and cosine functions. And this is coming from example 2 on page 838. This is really to try to give you an understanding of what to expect on the graph. I'm not as concerned about you drawing a graph using the information, but more recognizing what you should expect once you actually graph it on your graphing calculator. And so we have here, in this case, a cosine function, and I've already graphed it. But let's take what information the function equation itself actually gives us, and let's see if this matches what I graphed. Now, one of the attributes about a cosine function, it's always going to begin, if we're looking at the xy axis, and when I say always, I mean that's not exactly true because we can have a phase, what is called a phase shift, something we'll study a little bit later. But in its parent form, it's going to start, all the positive values of theta are actually going to start along the y-axis. And this amplitude is going to tell us where that, and we've already learned that 3 is going to be the amplitude. It's going to tell us where the y-intercept is going to be. And in this case, the y-intercept is going to be at 0, 3, which is also the amplitude. Now, determine where the next x-intercepts or theta-intercepts may be. For a cosine function, we have this formula where we got 1/4 times 360 over the period, comma, 0. Now, in this case, our b is 1, so we've just got 1/4 times 360, b is 1, and that is going to be 90, 0. And remember, our window setting is set up at pi over 2, so the x scale is at pi over 2, or 90. And we can see here that we do have an x-intercept at 90, 0. And then our next x-intercept is going to be at 3/4 times 360 over b, 0. And again, in this case, b is 1. And so 4 going to 360, that's 90 times 3. And so it's going to be 270, or 3 pi over 2. And again, if this is 90, then that's 180, and there's 270. We see another x-intercept. And our period, of course, is going to be 360. And we can see that as we go from here out to here, and this would be 4, or 360, or 2 pi. And there we've drawn that graph. And really what we've done here is we've taken this information to verify, okay, yes, I've got a y-intercept up there at 3. That corresponds to the amplitude for a cosine function. Sine function is going to be different. We'll see that in a moment. I've got an x-intercept at 90, or 1, 0. And I've got another x-intercept at 270, or 3, 0. Again, this is because I've set this y-scale to be pi over 2 because I'm doing sinusoidal functions. All right, let's go here to the next slide and let's look at a sine function. All right, so here we got a sine function. We got 1/2 sine of 2 theta. So again, now, one of the characteristics of a sine theta is it's going to start at the origin. And here we see that. So one of our x-intercepts is actually going to be 0, 0. And this amplitude is going to give us where y, the maximum and minimum height of y, which we see here, we got about 1/2 at a max and about 1/2 at a minimum. Now, in order to determine and verify these x-intercepts, we can start with this. We can say that 1/2 times, and what is our period? Let's go to that first. period, remember, is equal to 360 over b. And b in this case is 2, so that's 180. All right, so I got 1/2 times 360 over 2, comma, 0. All right, well, let's see. 2 into 360 is 180, and then we're multiplying that by 1/2, and so we should see 90, comma, 0. Or as we're looking at it on the coordinate plane, that's going to be 1, comma, 0, and we see that verified right there. Then our next intercept is just going to be 360 over 2, comma, 0, or 180, comma, 0, or 2, comma, 0. And because this repeats, and there we see an x-intercept. And so we're seeing this, that we're hitting the x-axis. We got an x-intercept at every 90 degrees. There's 90, there's 180, there's 270. We've got another x-intercept right there. And if we could see it out here, there'd be an x-intercept of 360. So anyway, that gives you an idea of what you're looking for as you may graph that on your calculator.
Did he play?